I hope all of you are doing well. I am Mr. Ish. Thank you for joining me for this most important video where I'm showing you some shortcuts for infinite geometric series sums. You know, an infinite geometric series looks something like this: n equals 0 or 1 going up to infinity. Your rule is usually 1 over a to the power of n. I'll show you three shortcuts. One has to do with your common ratio, the other one has to do with your sum of your series where n is equal to 0, the other one has to do with your sum of series where n is equal to 1 as your starting point. These are three most important rules. Two of these will apply when the series sum is known to be finite or convergent, and that's something you should keep in mind. When you know a series will be finite and convergent, these two will apply the shortcuts. This right here will apply in any general case where you're looking here at an infinite geometric series. That shortcut with regards to the common ratio applies no matter what. What's finite, what's convergent? When you add up all of this sum of series, it's equal to a value that you can comprehend versus a conceptual value that's infinite. If the sum is equal to infinity, then it's not finite, it's not convergent. But if the sum is equal to a value that you can comprehend, it's a finite value, it's convergent. Let's start here with two examples, one being this. When n is equal to 0 up to infinity, I have 1 over 3 to the power of n. When I expand this out, starting from n equals 0, I have 1 over 3, 0 plus 1 over 3 to the power of 1 plus 1 over 3 square, going all the way up to where the eventual value is 1 over 3 to the infinity. Contrast this to this: n is equal to 1 up to infinity, 1 over 3 to the power of n. Here your first term is 1 over 3 to the power of 1, then the next term is 1 over 3 squared, then next term is 1 over 3 cubed, going all the way again up to 1 over 3 to the infinity. When you look at both of these, there's a common ratio, and it's pretty evident. Your common ratio is by means of this general formula, but once you learn the shortcut, you don't even have to worry about this formula. The general formula is you're looking at your an plus 1 term, your next term, dividing it by the previous term, or you can say your nth term divided by the term before, an divided by an minus 1, or an plus 1 divided by an. Either way, it's equivalent. Look at any two terms, like 1 over 3 squared, which is 1 over 9, divided by 1 over 3. When you do the common ratio, what do you have? You have 1 over 3, and it's equivalent to 1 over a. What's your first shortcut? Your first shortcut is this: what you see right here in the parentheses, absent of everything else, for an infinite geometric series is your common ratio. Your common ratio is exactly equal to what you see in your parentheses, bound by everything else. That's what you have to understand. Another item you need to understand: this constant that you're seeing here, the 3 here, the 3 here, it's equivalent always to what you see over here. Your constant is always equal to that a value, and you can remember this because we will be using this. The constant that you see right here in your rule is the a value that you will see in your shortcut formula that I will show you momentarily. Let's talk about finite and convergence. You see how here we got a value which is 1 over 3, which is equivalent to 1 over a. If your common ratio is less than a value which is 1, then you will have convergence, which means that when you do your sum of series calculation, it will be a finite value you can comprehend versus a sum of series being infinity, which you cannot comprehend. Here you're clearly looking, always just look right here at the very beginning at your rule. It's a 1 over a, it's a 1 over 3. Is 1 over 3 visually less than 1? Of course it is. It's not. Our rule is not this, where we're looking at n equals 0 to infinity and then 3 over 2 to the power of n. Here you clearly see that the ratio, which you see right here, the item in the parentheses being your common ratio, here would be 3 over 2, but it's larger than 1. Here clearly 1 over a is less than 1. It's convergent, and it'll give us a finite sum of series. So what is your shortcut number 1? It's exactly what I've told you right here. Your common ratio is always equal to what you see right here in the parentheses, and you don't even have to go through this calculation of doing this. You don't even have to do that for an infinite geometric series. If that ratio ends up being less than 1, and visually you can see 1 over 3 is less than 1, it's convergent, you'll have a finite series. Now let's talk about the sum of series before we talk about the actual shortcut formula. Look right here in the very first case. We'll call this the first case A. Here's case B. When you're looking at first case A, the sum of the series general formula, this is not your shortcut formula, but this is your general formula, is equal to your a, one term, divided by 1 minus common ratio. For this, you would have had to calculate the r, which would have been extra word. But looking right here, the first term is 1 over 3 to the power 0. Anything to the power 0 is 1. It's 1 over 1 minus common ratio. We already know is 1 over a. For this case, it's 1 over 3. When you're doing this, you have 1 over 2 over 3. When you do this, you have 3 over 2, and that right there is the sum of your series. The common ratio here, 1 over 3, was less than 1. It's a finite value. You can comprehend it. That's case A. The sum of this entire series is equal to 3 over 2. Let's look here at case B. The general formula is still the same, but the item that will change here is a numerator item, because your A1 term is no longer 1 over 3 to the power 0, it's 1 over 3. It's 1 over 3 divided by 1 minus your common ratio 1 over 3. You'll have 1 over 3 divided by 2 over 3. You compute this, you'll have 1 over 2, and that's your sum of your series. It's still finite, and it's still a convergent series, because again the common ratio 1 over 3 is less than 1. But this value in terms of its sum is less than this, because here you're looking at a full 1 adding into the sum. Here you're looking at a fraction less than 1 adding into your sum. As this A value gets larger, here the A value is 3, but as the A value gets larger, there will be a significant difference between the two in terms of value. If I were doing like here 1 over 20 as my rule to the power of n, then this value here would be significantly large. This value here would be very small in terms of its value. As the A value gets larger, the discrepancy between both of these scenarios becomes wider and wider. But these are your general formulas, and you know the common ratio formula. But again, here's your shortcut formula number 1. Let's talk about the shortcut formula number 2 and 3 with regards to both of these. Again, case number A, we are looking at n is equal to 0 up to infinity 1 over a to the power of n. Your basic general formula is sum of infinity terms of this infinite geometric series is equal to a1 divided by 1 minus r. Bring the items in. You know the very first term is always 1 over a to the power of 0, which is equal to 1. Bring it in. You'll have 1 over now 1 minus common ratio. Bring in your shortcut. You have 1 over 1 minus a. This is for the case where n equals 0. Fraction algebra, 1 over a minus 1 over a. Flip things around, you have a over a minus 1. Shortcut number 2. For the sum of infinite geometric series where n is equal to 0, your sum of series, and you don't even have to worry about common ratio because it's just a visual check. This right here is your common ratio, is equal to a divided by a minus 1. There's no r coming into the formula, and it's as simple as that. Now let's look at the next case where n is equal to 1 as your starting point. Case number 2, n here is equal to 1 going up to infinity 1 over a to the power of n. Your sum of series is equal to, again, a1 divided by 1 minus r, but your a1th term here is going to be 1 over a to the power of 1, which is 1 over a, so bring that into the formula. Your sum of series is equal to 1 over a divided by 1 minus common ratio, again 1 over a. Do the fraction algebra, you have 1 over a divided by a minus 1 over a. Flip things around, you have 1 over a times a divided by a minus 1. These cancel out, you have 1 over a minus 1, and this represents your formula. Again, no common ratio is coming into play because again it's just a visual inspection. For your sum of infinite geometric series where your starting point is n equals 1, your formula becomes 1 over a minus 1. And what are the two most common scenarios? It's either this, n is equal to 0 or n equals 1 as your starting point. It's very rare that you'll see n is equal to 5 or 6 or 7 as your starting point. Hence, the shortcuts are pertaining to n equals 0 and n equals 1. Now let's show you this in terms of actual example. Look right over here. N is equal to 0 up to infinity. I'm looking at 1 over 7 to the power of n. I know right here, just by looking at this, I have an a value equal to 7 because what you see here is equal to 7. Your common ratio is equal to 1 over 7 and it's visually less than 1, so we're done with that. It's convergent, we'll have a finite value. I know I'm looking at this case, so what am I doing? I'm doing 7 divided by 7 minus 1. 7 over 6. 7 over 6 is your sum of series and it will be right. Guaranteed it will be right. Look at this next case and last case. N is equal to 1 up to infinity. I have here 1 over 11 to the power of n. I know just by looking at this right here is my a value. Because the rule is 1 over a, the constant is your a. I know here my common ratio is 1 over 11. Just by looking at the item in the parentheses, it's 1 over 11 and it's less than 1. It'll be finite. What's my formula? It's this. I'll do 1 over 11 minus 1. It'll be 1 over 10. And that will be the sum of this series and is guaranteed to be correct. So that brings us to the end of this video. Your three shortcut formula are this. Common ratio is always what you see here in the parentheses, 1 over a, and the a value that you see right here represents the constant which will come here in the formulas. The sum of infinite geometric series where the n equals 0 is the starting value is always a divided by a minus 1. Where n is equal to 1, that sum of that series is 1 over a minus 1, and it's as simple as that. Thank you for watching.